Hello everyone, welcome to VLSI Toolbox channel. Today I will be showing you FPGA in loop demonstration using Nexus 4 DDR RTX 7 FPGA board. It is very much useful for FPGA with limited physical I/O ports. It is one way you can say that it is a block level design implementation. So this can be done using the IP core virtual input output, which is used for probing the signal. In this fashion, you can connect the IP core with your top module. Top module should be in block level, and you can call the IP core and connect in this fashion. The output of the IP core is connected to the input of the top module, and the top module output is connected to the input of the VIO IP core, and clock is given from the system itself. So in this way you can probe with the signal. Next, it is the internal architecture of VIO, where you can see the input is the input registers and activity detectors. This is for the input port of the VIO, and it can sense the activity through ZTAC port, and this is the output register of the VIO, which is given to the input of the top module. This is for probing the input of the top module. Next, these are the I/O port available in the VIO IP. It has input port number M can be of 0 to 256, of width N can be of 1 to 256, each one of width having 1 to 256, and also same as for output probe. There is lots of I/O port. You can use it for probing your design. Next is the ILA, integrated logic analyzer. This is used for viewing the signal in the Vivado itself, that is the waveform, live waveform from the Xilinx FPGA. So it has two modes, one is native mode and another is AXI mode. AXI means Advanced Extensible Interface Protocol mode. You can use in both this mode, and it has the I/O ports. Description is given here. It has been taken from Xilinx reference manual. You can follow this indeed for details. Another IP is slice IP, which is used for tracing the data or to divert the data path and assign the signal to the external pin of FPGA. So with this 3 IP, I will be showing you the demo. So let's go to the demonstration. Now let's go to the software Vivado, create project. I will be using my previous code shown in my previous video. So kindly view the previous video so that it can be easier for you to understand this one. I will not be explaining the code now. Give a name test. RTX 7 speed -1 package 324 finish. No need to give any input output ports. So I am now just pasting my previous code. So this is my previous code. I have explained in my earlier videos. Please check it. Save it. So for block level design, now go to create block design. So now press plus button, this one, search it for VIO. Next, go to sources, click on the top module, right click it, add module to the block design. So this is your top module. You connect this to this, you make it external, and connect this clock to this, same clock will be provided. And now let us configure the input port of your VIO according to the output ports. Before that, let us make this pin also external so that we can view in the LED of FPGA. Also this for display, LCD display, 7-segment display, and this is for enabling the 7-segment display, make it external. So now you configure this input port, you require only one, and width is 7-bit. Okay, so connect this, save it. So this is the connection only with VIO. Now if you want to visualize the waveform in the Vivado itself, then you have to connect one analyzer, that is ILA IP. So let's connect it, plus button, ILA, integrated logical analyzer. ILA require only, you have to configure it in native mode. Only one probe is required with 7-bit. Width is 7-bit. Okay. Now connect the ILA with the counter. This probe, and clock you connect common. Okay. Now for driving the LCD display, means LED 7-segment display, we have to connect another IP called slices. This is the slice IP. Now you keep the slice IP here, configure the port, width is required, we require only 7-segment output, so 7-bit, 0 down to 6. Output width is also 7-bit. Okay. From 6 down to 0, 7-bit. Okay. Now you connect the count show pin, and this pin make it external. So arrange this layout, check for any implementation, any error. So it is successfully checked. Now save. After this, go to this design, right click it, create SDL wrapper. So it is updating. Now create this design underscore one wrapper as top module. Now run synthesis. So it is running synthesis. It will take time. Now open synthesized design. So this is the device. Now we will assign the ports to the FPGA package pin. So for clock, scalar port 2, it will be LED pin, LED pin 817 for 1 Hz clock output. So give age 17, and this will be IO standard is low voltage CMOS 33. So next is DP pin. DP pin is the enabling pin of 7 segment, which is H15. You can follow the datasheet of RTX 7 Nexus DDR board to know the pins, and we have to also give the AN pins one by one. So give the enable pin of 7 segment AN0, AN0 to J17. Very carefully you assign the pins, otherwise it will not run. Say 18 for 1. J18. Again it is 33. T9. Then for 3 J14. J14. Then 4 P14. Then fifth one is T14, and sixth one K2. Again these are all LV CMOS, low voltage CMOS, 3.3 volt. Next, this is 7-1 is U13. So I have assigned the pins, and for clock it is a system clock. E3. Now this D out, this is the output of the counter, 7 segment counter decoder output. So sixth one is T10. T10. LV CMOS 3G standard. Next R10. Next fourth one is K16. LV CMOS. You carefully keep all these higher standards. Third one is K13. Again it is same as standard. Second one is P15. First one is T11. D0, one is L18. All standards should be given. And I think I have given all these pins. So as of now it is finished signing IO. Press save. Okay, give a name to the file as XTC. Now close it. Run implementation. So it will again take time. And write bit stream. It takes time. So it's completed. Now open hardware. Before opening hardware manager, connect the FPGA. Open target. Now you can see the prober is ready. Also you can run the waveform to check the output. Live output is coming here, and you can set here, this is the ILA output window. Auto toggling will be there. So here you can see it is toggling automatically, and if you want to check the VIO output, plus select on the signal. So here you can see the activities, the counter is counting up, and you can also bring the window side by side so that you can visualize the thing carefully what is going on or easily. So this is the VIO probing, and this is the ILA window. So if you press the reset to 1, this is the reset pin, so everything will be stopped. You can see everything will be stopped, and if you counting also stop, no data updating is going on. Again if you press the 0, it will again start to count up, also data will be updated in the window. Let's check the behavior of the hardware, what is going on in the hardware. So let us change the reset value and see what is going on in the FPGA as well as in the ILA waveform window and the VIO. So press to 1. So here you can see the counting and LED blinking is stopped due to the reset. Also in the ILA, same observation has been noticed. So now let's again press to 0. So again it is counting up. So with this you can check any number of input output ports in your design and probe and visualize the waveform live in the Vivado using ILA IP, and you can prove the input outputs using VIO IP. So that's all from the demonstration side. So this is all about the demo, and hope you like it. Thank you.